Hello guys, and welcome back to this channel. In today's video we are going to continue our lesson on polynomial functions. In this video we are going to talk about the remainder theorem. Now before we move to the remainder theorem, I want us to look at functional notation. Now we have one example here. Let's try to solve this example. Now given that f of x is equal to 3x cubed minus 2x squared plus 5x minus 1. We are going to evaluate I, f of 1, and then I, f of 2. Okay, so let's do this together. So to solve for f of 1, basically what we are going to do is we are going to substitute the value of 1 into f of x. So wherever we see x, we are going to replace that with 1. So now let's find f of 1. So f of 1 is equal to 3 times 1 cube minus 2 times 1 square plus 5 times 1 minus 1. Now let's simplify this. 1 cube is 1, so 3 times 1 is 3. 1 square is 1. Negative 2 times 1 is negative 2. 5 times 1 is 5. And then we have negative 1. 3 minus 2 is 1. 1 plus 5 is 6. 6 minus 1 is 5. So it means that f of 1 is equal to 5. Now let's solve for f of 2. So for f of 2, we are going to substitute 2 in f of x in place of x. So we have 3 times 2 cube minus 2 times 2 square plus 5 times 2 minus 1. 2 cube is 8, so 8 times 3 is 24. 2 square is 4. 4 times negative 2 is negative 8. 5 times 2 is 10 minus 1. 24 minus 8 is 16. 16 minus 1 is 15. 15 plus 10 is 25. So it means that f of 2 is 25. Now let's move on to the remainder theorem. So now to the remainder theorem. In general, if a polynomial function f of x is divided by x minus a, then f of x is equal to the quotient times x minus a plus the remainder. Now the remainder is equal to f of a. So basically what we are saying is that if f of x is a polynomial function and f of x is divided by x minus a, then basically what we are going to do is we are going to equate x minus a to 0, and then x is equal to a. Then you substitute a in place of x in this polynomial function. So here we have an example. Let's solve this example. Now if f of x equals x cubed minus 3x squared plus x minus 5, what is the remainder when f of x is divided by x minus 1? So we have f of x as x cubed minus 3x squared plus x minus 5. And then it is divided by x minus 1. So we are going to use this approach. So we are going to equate x minus 1 to 0. We have x is equal to 1. Then we are going to substitute 1 in place of x into this polynomial function. So f of 1 is equal to 1 cube minus 3 times 1 square plus 1 minus 5. 1 cube is 1. 3 times 1 square is 3 plus 1 minus 5. 1 minus 3 is negative 2. Negative 2 plus 1 is negative 1. Negative 1 minus 5 is negative 6. So when x cubed minus 3x squared plus x minus 5 is divided by x minus 1, we have the remainder to be negative 6. So we can as well confirm our answer using the long division method. So using the long division method, we have x minus 1 on the outside, and then we have the polynomial function f of x, which is x cubed minus 3x squared plus x minus 5 inside of the square root. So we are going to divide x cubed by x. So x cubed by x gives x squared. So x squared times x is x cubed. X squared times negative 1 is negative x squared. X cubed minus x cubed goes to 0. Negative 3 minus negative 1. So it becomes negative 3 plus 1. Negative 3 plus 1 is negative 2. So we have negative 2x plus x. Now negative 2x squared divided by x is negative 2x. Negative 2x squared times x is negative 2x squared. Negative 2x times negative 1 is plus 2x. Negative 2x squared minus negative 2x squared goes to 0. X minus negative 2x is negative x. Negative x divided by x is negative 1. Negative 1 times x is negative x. Negative 1 times negative 1 is plus 1. So this goes to 0. We have negative 5 minus 1, which is negative 6. So since we have both answers to be the same, it follows that if a polynomial function f of x is divided by x minus a, then the remainder can be found by substituting the value of a into the polynomial. Now let's solve some more examples on this same concept. So let's try this example. Find the remainder when I, x cubed minus 2x plus 4 is divided by x minus 1. 4x squared minus 8x plus 1 is divided by 2x minus 1. So we are going to use the same principle. X cubed minus 2x plus 4 is divided by x minus 1. So to find the remainder, we are going to equate x minus 1 to 0. We find the value of x, which is equal to 1. Now we are going to substitute 1 in place of x in this equation or in this function. So f of 1 is equal to 1 cubed minus 2 times 1 plus 4. 1 cubed is 1. Negative 2 times 1 is negative 2 plus 4. So 1 minus 2 is negative 1. Negative 1 plus 4 is 3. So it means that when you divide x cubed minus 2x plus 4 by x minus 1, you have the remainder to be 3. Now let's solve for I. We have 4x squared minus 8x plus 1 divided by 2x minus 1. So we are going to equate 2x minus 1 to 0. 2x equals 1. We divide through by 2. We have x equals 1 over 2. We are going to substitute 1 over 2 into this polynomial function. So f of 1 over 2 is equal to 4 times 1 over 2 square minus 8 times 1 over 2 plus 1. 1 over 2 all square is 1 over 4. So we have 4 times 1 over 4 minus 8 times 1 over 2 plus 1. 4 times 1 over 4 is 1. 2 goes into itself once into 8 4 times. So we have negative 4 times 1 plus 1. 1 plus 1 is 2. 2 minus 4 is negative 2. So f of 1 over 2 is equal to negative 2.